Okay, so this is page 5 of the polynomial review packet. We need to write a piecewise function for this graph, and it says you can leave the polynomial piece in factored form. So we have graph polynomials in this unit. You can see this is your polynomial piece. This here is a constant, and this is a linear equation. So we have 3 pieces, and I'm going to write my answer over here because there's more space. So y equals, all right, the first piece on the left is this one right here, and the y is always -8. So that one is going to be -8. And that's going to be if x is less than, and let's go up and see what number this is. So actually, my drawing was a little bit off, but it looks like it's about -2.5. So if x is less than -2.5. All right, here's our polynomial piece. It has zeros at -2. That means that x plus 2 is a factor. And it has a double zero at 1. I know that because it bounces at 1. So it has x minus 1 as a factor, but it's a double root. Now I want to make sure that this gives me the right y-intercept, because if it doesn't, I would have to put a number in front here, lead coefficient. So I'm going to plug 0 in for my x value and see if I get 2 for my y value. 0 plus 2 is 2. 0 minus 1 is -1. So -1 squared is +1 times 2 is 2. So when I put 0 in, I get 2 out. So it looks like my y-intercept is already working. So this is my equation. Now this equation is between this point and this empty point. So x is going to be in the middle, and x is greater than or equal to -2.5. I think I need more space for that. And then x is less than, but not equal to, because of the empty dot, x is less than 2. All right, the last piece is a linear equation in the form of y equals mx plus b. And you can't see what your y-intercept is because it's not connected to the y-axis, but if you were to continue this pattern, it looks like it would be 5. So my y-intercept is 5, that's the b. And then the slope is the rise over the run. So that's going to be down 1 and over 2. So your slope is -1/2. So that equation is -1/2 x plus 5. And that is if the x is between 2 and 6, and you want to include the 6. So here's 2. Don't include the 2, but do include the 6. Okay, and that is your answer for A. Let's look at B. Write the domain and range. All right, the domain starts over here at -infinity. And it continues here. Because this empty point is filled by this point, you don't have to leave any points out. So we're going to go to from -infinity, keep going to the right, and we have to leave out the number 2 because 2 is not in the domain. So you go to 2, leave 2 out, and then continue from 2 until 6. And include the 6 because the dot is closed. For the range needs this number, -8, in it. Oops, I want to include the -8. And then it jumps from -8 to -6 and includes -6, so you need square brackets again. All right, it goes to, it looks like a maximum of 4 here, and I'm going to go ahead and make sure that there's no other y value bigger than 4. The 4 is left out here, but because it's included here, we're going to include it. So you need to include the 4. All right, for what intervals is f of x greater than 0? So remember, f of x is the same as y. So we're going to look at our y values here. You can see greater than 0, these are the positive y values. So let's take a look. Looks like over here, the y is greater than 0 here, not that one point, but then again here, and also here. These are all y values greater than 0. Now you want to write the x values when you're writing your interval. So my interval is from -2 to 1. Leave out the 1 because y equals 0 at the 1. So let's write that first, -2 to 1. All right, then from 1 to 2, but I have to leave out 2 because that's not even in the domain. And then again, starting right after 2, all the way until 6. And 6 is an endpoint, and we're going to include 6 because the y value is greater than 0 there. So 2 to 6, and then include the 6. All right, here's our polynomial, and the first question is, what is the degree? So this is x squared. This factor here, you could literally multiply it by itself 3 times if you wanted to, but the first term is going to be the one that is cubed. So the largest degree of this whole polynomial is cubed, and this is to the first power here. So I can take these numbers and add them up to find my degree, which is 6. Okay, to find the lead coefficient, you would need to figure out all of the coefficients of the factors and then multiply them. So 1x squared, your first term in this polynomial, so the lead coefficient of this polynomial would be the cube of 3x. And then this is x to the 1. So when you cube 3x, that becomes 27. And 27 times 1 is still 27. So you have 27 x to the 6. So your lead coefficient is 27. And because the degree is 6, the maximum number of turns is 1 less than 6. So that one is 5. All right, so lastly, we need to simplify some binomials. So you're going to need your Pascal's triangle for this, and the way you create your Pascal's triangle is by putting a 1 at the top, and then you put 2 1s, and then you add those 2 1s and you put your 2 here, and then you always have 1s on the outside. So you can put your 1s on the outside here, you add 1 and 2 to get 3, you add 1 and 2 to get 3. So I made it down to my 5th row, but I need to get to my 7th row for A. So I'm going to continue on. 1 and 5 is 6. 5 and 10 is 15, 20, 15, 6, and 1. It should be perfectly symmetric if you're doing it properly. 7, 21, 35, 35, 21, 7, and 1. So that's the row we're going to use. So when you expand, remember that the first variable starts to the 7th. And as you go along, the first variable will lose a degree and the second one will gain a degree. So I'm going to start with 1, that's my coefficient, x to the 7, plus, next coefficient is 7. 7, the x loses a degree and the y gains a degree. Okay, then 21. The x loses a degree and the negative y gains a degree. Okay, 35. The x loses a degree and the y gains a degree. Okay, another 35, x to the 3rd, and negative y to the 4, 21, I think I'm going to erase this, but before I do, I'm going to copy the row that I'm going to need for this one here. I need 1, 4, 6, 4, 1. So I'm going to use that row down here. All right, so back over here, I used 35 and 21, so my last numbers are going to be 7 and 1. So let's just remember that. I need 7 and 1 still. All right, so lose an x and gain a y. All right, 7 was the next one. Okay, x to the 1, negative y to the 6, and then 1 y to the 7. Okay, so now I need to simplify. This is x to the 7. Negative can come out front, so it'll be minus 7x to the 6 y. This is negative y squared, so that's going to become positive y squared. So plus 21x to the 5th y squared. Oops, next one. To the 3rd power is going to make another negative. 35x to the 4, y to the 3. Let's see. This is y to the 4th power, which is going to turn positive. So I have plus 35x to the 3, y to the 4. And you can see this pattern, negative, positive, negative, positive. The next one is going to be negative. 21x squared, y to the 5th. And then positive 7x, y to the 6, and finally positive y to the 7. Okay, so this is the row of Pascal's triangle we need for the next one. Start with the 1, and then the 3a is to the 4th power, then the 4. The 3a is to the 3rd power, and the 1/2 b is to the 1st power. Then the 6, 3a is to the 2nd, 1/2 b is to the 2nd also. Then the 4, that's from right here. 3a is to the 1st, and 1/2 b is to the 3rd. And then finally 1 times 1/2 b to the 4th. And now we need to simplify. 3 to the 4th is 81, so 81a to the 4. 3 to the 3rd is 27, and then 27 times 4 is 108. But that's also times 1/2, so that's going to be half of 108. A is to the 3rd, and b is to the 1st. Okay, 3 squared is 9, and 9 times 6 is 54. 1/2 squared is 1/4, so that's times 1/4. The a is squared and the b is squared. All right, 4 times 3 is 12. And 1/2 to the 3rd is 1/2 times 1/2 times 1/2, that's 1/8. A to the 1st and b to the 3rd. And then this is 1/2 to the 4th, which is 1/16. B to the 4th. So we're going to do one more step now. And we're going to simplify. So I have 81 a to the 4. This divides, I get 54 a to the 3rd b. This simplifies to 27 over 2 a squared b squared. This simplifies to 3 over 2 a times b to the 3rd. And then the last one was already simplified, 1/16 b to the 4th. Okay, and that's your final answer.